Hello everyone, my name is Vidhaan Agarwal and today we are going to be discussing a very interesting topic. Are we alone? So let's get started. Probability of life on other planets. There are about 400 estimated billion planets in our Milky Way galaxy alone. So there are about 10 to the power 24 planets in the observable universe. Let's feel this number now. Next, let's see what are exoplanets. Exoplanets can be defined as planets outside our solar system. There has been a lot of excitement and speculation about how exoplanets could support life. Some examples are the TRAPPIST system. Finding exoplanets. Exoplanets can be detected in many ways. Some of the most common ones are transit method, astrometry, radial velocity, gravitational microlensing, and direct imaging. All of us know about solar eclipses, which happen when the moon passes in front of the sun, blocking its light. The same thing happens here. As this planet passes in front of the star, its light level decreases because it blocks some of the light. The curve on the left side of the screen indicates this and is called the light curve. Bigger planets block more light, so they cause a bigger dip in the light level, as we can see here. The bigger planet caused a bigger drop in the light level and therefore created a deeper light curve. Also, when there are multiple planets in the system, as we see here, the light curves begin to get a bit complicated. We can still pick out the same information for each planet, it just takes more work. Radial velocity. In this method, we use the fact that stars wobble in their orbits due to a planet's gravitational attraction. Let us understand the Doppler effect. Doppler effect is an effect due to which moving sources of waves that are moving away from us give us a bigger wavelength, and moving sources of waves which are moving towards us give us a shorter wavelength. As shown in this animation here, as the star moves towards us, its wavelength decreases, and it moves away from us, its wavelength increases. Astrometry is another method which uses wobbling of stars to find exoplanets. In this method, the relative position of the star is measured with respect to other stars around it. If this position is changing, then we can understand that the star is wobbling and it has an exoplanet orbiting it. This method is extremely hard to do because it requires extremely precise optics. Gravitational microlensing. In this method, we use the fact that light bends around very massive objects. This allows objects to be lensed, which means focused onto the observer. Also, it can create rare cases like these, causing the background star to form a ring around the foreground star. But how does this help us find exoplanets? Let us see this graphic here. Here we can see there is a system with a star and a planet. As it moves across the horizon, it focuses the light onto us, the observer. However, we can see there is a brief blip of light from the planet's lensing action. Using this, we can find exoplanets. Direct imaging. In this method, we try to take photos of exoplanets directly. As you may imagine, this is quite difficult, but we can do it by blocking the glare of stars, allowing us to see the objects that orbit them. Driving factors for life existence. Let us determine the possibility of life on exoplanets. Let us find the factors of life first. Moderate temperature and pressure, size of planet, orbital period, the type of star it's orbiting, and presence of biosignatures. Let us see how do we determine the gaseous atmosphere of a planet. It is found using the transit spectroscopy method. When the stellar light passes through the exoplanetary atmosphere, most of the light makes it through, but some of the light is absorbed. This absorption causes an absorption spectrum, which we can see from the image there. Moving next, let's see what are biosignatures. Now that we know all the parameters, How can we determine the possibility of life on that planet? Biosignatures are compounds whose presence indicates the presence of life. For example, high concentrations of methane and oxygen together is a good indicator of life. So, we have reached the end of the presentation. Let's recap what we discussed till now. Probability of life in the universe, life on Earth, what are exoplanets and methods to find them, factors for life existence, determining the factors, biosignatures. But still, the question remains, is there life in the universe? Most probably yes, but only further studies can surely answer the question. Are we really alone? Thank you.